billions or gigatons of the rock have to move, opening up the pathway for the eruption. And that is the reason we have earthquakes. These are the tremors we are seeing all through the plate boundary. You can actually see the plate boundary where the earthquake's happening, and waves of them are coming from the extreme west to the extreme east of this, and opening up the rocks takes a lot of power. The pulling power of the whole continent of Eurasia and Americas are pulling apart these billions of tons of rocks just to open up. A tiny amount is not much. 60, 70 centimeter is enough for an eruption. And that is a usual thing we see in the nature. In the nature, what we are seeing, these movements of the rock in the jagged way, in a zigzag way, through the transform faults and other faults, you can see that in the nature creating what we call as dike. This is the dike, means a solidified pathway of the magma frozen in time. And this is what we'll see here in this area. You see the heat rising from the pathway of the previous eruptions here, and the result is what we have seen before, like this. And this is all that we need. 60, 70 centimeter, up to 1 meter of the land opening up, letting the pressure relieved over the magma, and the magma rising to the surface, melting and forming what we call as lava. I have several videos about the mechanism that I described here. Please watch them. They're interesting. They are related to what I've discussed here now. Reykjanes Peninsula of the Iceland is a very interesting place. We have an extension of the earth crust in that area, which is part of the mid-Atlantic ridge, and the stretching of it has created rift valleys. The most famous one at the moment is what I have called Grindavik Rift Valley. We can see in this area photographed from the Met Office of Iceland, you can see the rift valley and the fault lines and the range. This is the top of the fault line and the basin where the drop down of the faults, and several faults that are there exist. Simplified version of that is this. What we think is this is the stretching of the lithosphere creates this uplift of the magma and eruption. And the Svartsengi volcanic system is formed here in this setting. We have usually eruptions now for the last 4, 5, 6 months. This is how it happens. It stretches the ground due to the uplift. We can map them by the GPS data, as you can see here. And the red line shows where the extension has happened and the uplift. And the uplift of this area creates a bulging of the ground, and the bulging that leads to the eruption, we can actually see that in the form of the eruption that happens in the Sunnuka craters. This is a Svartsengi GPS data we are seeing. Interestingly, when we have the uplift, after the eruption happens, we see a downfall, as if the ground falls down due to the magma flowing from the Svartsengi toward the Sunnuka crater to the east. In the Eldey, we have the opposite of that. What is interesting, east-west direction, actually, you can see it here. We have a contraction of the ground in the east-west direction, and the moment eruption happens, it starts to stretch back. So what we are seeing in the opposite side of it, in the Grindavik, is the exactly opposite of what happens in the Eldey. We see that up to the point of the eruption, the land is actually stretching until the point of the eruption. Then it starts after the eruption to contract. I've tried to show this in this diagram. Extension up to the point of the eruption. Then during the eruption and after that, we have contraction of the ground. This makes sense because the land is rising due to the magma accumulation. So it stretches and then contracts. In the adjacent regions to the opposite side of the fault lines, you will see the opposite of that. When there is extension, you see on that side compression, and the opposite again when it happens. This is an interesting observation. The land is breathing. You can see that the effect of it on the Eldey and the Svartsengi and the Grindavik area. When we plot the earthquakes and the volcanoes on a map of the world, we find that they are concentrated at certain areas. This is the way we discovered the plate boundaries, and we discovered that the earth actually is cracked. The cracks through which eruptions of volcanoes may happen. Before that, also we may have earthquakes. And first we discovered that the certain coastal areas of the world, for example, Africa and South America, match together as if they have been joined together in the past. Alfred Wegener discovered this first. Now we know that the Earth continents are actually not in the original place that they have been. They have moved many times over since the creation of the Earth in 4.5 billion years ago. And this process is continuing. And where we can see the process actually in real time is in Iceland, where we have the creation of the Atlantic Ocean leading to the formation of this island. Inside the Earth is hot, practically due to the impact heat that was introduced to this planet during the formation of it. And this heat creates convection, and the convection leads, when it reaches the surface, the solidified crust at the top of the mantle creates cracks in the ground, as you can see here. And these cracks are where the separation or extension of the crust happens, and the magma forms, fills the gap created simultaneously. So there is no practically a gap. And the eruption in the Iceland is of this type. In the Red Sea, we have another example, Afar Triangle or Africa, or Rhine Valley in the Germany, we have that. We have these eruptions in the water most of the times, like what we have in the Reykjanes Ridge, which is a plateau inside the Atlantic Ocean. Part of it reaches the land. Practically, they are the same as the volcanic systems we have on the land. One of them is the Eldey volcanic system, similar to Svartsengi or Reykjanes volcanic system or Hengill. And this can potentially erupt inside the ocean. It has done in the 19th century and 20th century. And it is possible that we have another eruption recently. Eldey itself is something like a Thorbjorn hill near the Svartsengi geothermal power plant, where the Blue Lagoon is a volcanic rock. It's the top of the ridge of the volcanoes that have been, most of it has been eroded. When we look at the tremors chart, we can see that the earthquakes start from the Reykjanes Ridge and extends into the Reykjanes Peninsula toward the east. Always starts from the Eldey, like a wave traveling through the earth, reaching the other side. And the volcanic systems on the Reykjanes Peninsula are created like that, very similar to what we have in Eldey. Eldey, if it erupts, will be in the ocean, of course, at the depth 60, 70, 80, 100 meters. And when it reaches the surface, it may react with the water. Lava has chloride in it, and chloride can disintegrate, create chlorine. Chlorine gas is one of the byproducts of these eruptions. Also lots of water and CO2, not compared to what we have actually created by, releasing from the, oil and gas over the last 200 years, of course. This is an ongoing process. When it reaches the water, like what we saw in the Cambria Vieja volcano, it can cause this kind of reactions. I have a video about what happened in Cambria Vieja. Please watch that. Apocalyptic views of lava flow from the Cambria Vieja volcano. Now 2 months has passed. Volcano has not stopped. It's coming directly from the core mantle boundary, like a welding torch. Made a hole in the Atlantic Ocean and created the La Palma originally. Now is adding to the landmass of the island. But the lava is flowing down the hills, going toward the ocean. This is a flow that nothing can stop it. I will show you a map that shows how it moves toward the sea, where it has covered actually. When it reaches the sea, it just looks like Jurassic Park. Things are falling down, rolling down. The seawater waves are coming toward the headland created by these lava flows. Any moment you may see a dinosaur coming out of there, or King Kong. And that is how it looks. This is a 3D model we have created, and it shows the lava flow where it ended up on the sea. The older ones, you can see that they are created layered lava as cliffs that we see. It's apocalyptic view. It's a very strange phenomenon.